In this video, we're going to use our knowledge of right-angle trigonometry to solve for unknown values. And we're going to start with basic triangles and then work our way up into more complicated word type problems. So really basically, and to review a few things we know, if we have an angle like the sine of, let's say this angle here is beta, okay? The sine of angle beta is equal to the ratio of side lengths of the opposite side over the hypotenuse. So it would be, in this case, b over c. If we wanted to say, all right, what's like the cosine of angle beta? Well, that's the adjacent over the hypotenuse, so that would be 4 over c. And if we wanted to know, like, what's the tangent of angle beta? Well, that is the opposite over the adjacent, so b over 4. In the situation with this particular triangle, and this would work for any right triangle. Of course, we plug in different lengths and different letters for the sides depending on what angle we were talking about. And in fact, since beta is 35 degrees, we really have enough information to what's called solve this triangle, or at least solve for any of the missing values that we don't have here. So in this problem, it's asking us to find the lengths of b and c. And so there's a couple ways to approach a problem like this. You can say, all right, well, this is 35 degrees. I know this is 90 degrees. So if 90 and 35 is 125, and all the angles in the triangle have to add up to be 180, then this angle here must be 55 degrees. This is absolutely not a necessary step, but if you can do it, you might as well. If you prefer to work with that angle instead of the 35-degree angle for whatever reason, then there you go. But if we want to find the lengths of B and C, well, there's a few options here. Well, there's two. We could say, all right, with respect to that 35-degree angle, right, the tangent of that 35-degree angle is equal to the opposite side, which is b, divided by the adjacent side, which is 4, and the only thing we don't know in this equation is b. So we could rearrange it, and we can say, all right, then b is equal to 4 times the tangent of 35 degrees. Now, 35 degrees is not one of our nice angles on the unit circle, so we don't know the value of the tangent of 35 degrees. But we can use a calculator for that, so it's no problem. We're going to fire up the calculator. And first thing we want to check to make sure is that we're in degree mode. So notice here we're in the radians mode, so we're going to go to degrees. Now we want to know what is 4 times the tangent of 35 degrees. And that right there is the length of B. So B is equal to 2.8. Right, rounded, but obviously it's pretty close to 2.8. So that's cool. Now we want to find C, okay? And what I would encourage you to always try to do when you have a problem like this, because now that we have B, we could just go to the sine of 35 degrees. Couldn't we just say the sine of 35 degrees is equal to this new value that we just got, 2.8 divided by the hypotenuse of C, and then just solve that for C? We absolutely could do that. The problem with doing this is that 2.8, we already rounded it. We didn't get an exact value there. It would be better for us to say, and this is totally acceptable too, we could say the sine of 35 degrees is equal to this thing that was not rounded, right? 4 times the tangent of 35 degrees divided by C, and then solve that for C. That's totally fine. And we could do that, and it would give us the right answer. Alternatively, we can just use the information that's given to us in the problem. So instead of looking at the sine of 35 degrees, if we looked at the cosine of 35 degrees, well, the cosine of 35 degrees is the adjacent over the hypotenuse, so 4 over C. And now if we solve this for C, then C is equal to 4 divided by the cosine of 35 degrees. And why this is a little bit advantageous, it's not like a big difference, but it's because 4 and 35 degrees were both things that were given to us exactly in the original problem. And if we can, it's best to use the things that were given to us in the original problem on the way to solving for unknown values, because that's going to allow us to have the exactly right answers, and we didn't use any rounded values in the process. So what is 4 divided by the cosine of 35 degrees? I don't know. It is 4 divided by the cosine of 35 degrees. And so that is 4.88. So C is equal to 4.88. Now we could have also, and this is not going to go through this process, but if we wanted to instead work with the 55-degree angle originally, we could have just as well have said that the tangent of 55 degrees is equal to 4 divided by b, solve for b to get b. We could have said that the sine of 55 degrees is equal to 4 divided by c. Notice something here. If the sine of 55 is equal to 4 divided by c, and the cosine of 35 is equal to 4 divided by c, that means that sine of 55 degrees is equal to the cosine of 35 degrees, which is something we've talked about before, that the cofunctions of complementary angles are equal. Okay, here's another problem. It's pretty similar. We've got now we just have it's labeled, and the things aren't given to us directly, but it really is like the beta is 10 degrees. So if beta is 10 degrees, we know that's 90 degrees. That means alpha has to be 80 degrees. So we got alpha. Alpha is 80 degrees. And now we just need to find A and C. Well, B is equal to 4. So this is just like the previous problem. And you can solve this any way you want if you want to pause the video and solve it. But maybe we'll say the sine of 10 degrees is equal to 4 divided by the C that we don't know. So C is equal to 4 divided by the sine of 10 degrees. And then maybe, so whatever that is, right? And then A, we'll use that 10 degree angle to find A also. Say the tangent of the 10 degree angle is equal to 4 divided by A. So A is equal to 4 divided by the tangent of 10 degrees. And this is totally fine. Like, you could set this up and solve these. And what I'm getting at here is that certain information in the triangle will be given to you. And so use that angle and use the appropriate trig ratio to solve for the side that you don't know. So real quick, what are these things? I don't know. 4 divided by the sine of 10 degrees, and we're already in degree mode, so I don't have to worry about that. That's not right. What did I do wrong there? Hold on. Sine is opposite divided by hypotenuse. We solve that for sine b is 4. C, oh yeah, that makes sense. Sorry, yeah, it does. So that's 23 degrees, or 23 whatever units. And then 4 divided by the 4 divided by the tangent of 10 degrees. You don't have to put that close parentheses. It's just gonna have it. It is 22. So A is 22.68 whatever degrees. And so and you could have easily done the same stuff with the 80 degree angle as well, and that would have been just fine. Alright, so here's kind of an application of the same idea here. So we have a road, and there's a surveyor. Maybe let's say the surveyor's right here, okay? And he's gonna look through this instrument called a transit at a point that he knows. Let's say this point is right here, and it's 50 feet away. So this distance right here is 50 feet. Then he's gonna turn. This transit is this thing where it records what angle you're like turned through. He's gonna he's gonna look at this other point directly across the street from that point, and he's turned through an angle of 35 degrees in order to do that. And so what we're trying to find out then is how far is this road, right? How far is the street? So what is this? What is this x value? We don't know. Well, this is real simple. We just say that the tangent of 35 degrees is equal to x divided by 50, because opposite divided by adjacent, and then we just say that the answer to this, x is equal to 50 times the tangent of 35 degrees. So what is that? The tangent of 35 degrees, I'm just going to do that here, times 50, is 35-ish feet. Okay, so this street is 35 feet wide.